Hello students, Miss Slyman here with your right angle triangle notes on area of a triangle. So this first one should be really fast, and actually I encourage you right now to stop watching the video and try to do these notes yourself and then come back and watch it, because I think you'll learn more that way. So really turn it off, try it on a separate page if you want, but try and go through these notes. Okay, so you should be turning it back on now, and hopefully you found that the area of this triangle was 1/2 of the base and the height, and of course this one was our height and this one was our base, and then we just calculate that out. 1/2 of 8 is 4, 4 times 5 is 20, and we don't know any units, so our area is 20. Now if we look at this triangle, you had a hint on your page to help you. So if I want to look at this triangle, I still need to do 1/2 base times height, and I know that the base is 8, but I need to find the height. Well, if I draw in a right triangle here, there's my right triangle, and if I look at this right triangle, here's my height over here, and I can see that sine of 55 is height over 10, because height is my opposite, and 10 is my hypotenuse. So the height is 10 times sine 55. So I can substitute that in over here. And so my area is 1/2 of 8 times 10 times sine of 55. And so exactly that's going to be 40, because 1/2 8 is 4 times 10 is 40. So exactly it's 40 sine 55. And then approximately I put it in my calculator and get that it's about 32.8 square units, whatever they are, centimeters, meters, I don't know, because I have not been told. Okay, so we can repeat that. And here's a triangle again. So I'm going to do the same thing. I'm going to put in a height, a right angle, there's my height. So my area, well, let's calculate the height first. The height is going to be found because, let's do it from the beginning, sine 38 is height over 9. So height is 9 times sine 38. So the area of the triangle, 1/2 base height, 1/2 times 12, times the height, which is 9, sine 38. And maybe you're starting to see a pattern. Notice that we have the 12 and the 9, and the 38 is between them. I have the 1/2, and then I have the 12 and the 9 and sine of the angle between them. Let's look back at this one. I had the 8 and the 10 and 55 as the angle, 8, 10, sine of the angle between them, and the 1/2 because we're dealing with the triangle. So again, exactly, I can calculate this. 6 times 9, 54 sine 38 is my exact answer. My approximate answer is 33.2. Well, now if I come in with just a generic triangle, in this triangle, AC is my base. My height is going to be here. So if I know angle C, then my height is going to be given by, let's again do it from the beginning. So sine C is going to be the height divided by BC. So the height is side BC times sine C. Well, what we do in triangles and in trigonometry is that we always label our sides by using a lowercase letter of the angle. So if I look across from my angle B, conveniently, it's a lowercase b, which I can also use for base. So across from side angle A is side A, And across from angle C is side C. So if I come back in to find the area of a triangle, the area of the triangle is half the base, which in this case is also the letter B, times the height, but our height is side BC, that's A, and then sine C. Notice that B and A are adjacent to each other, and angle C is the angle in between them. So half, and normally we say half AB sine C. And so we have ABC. It works, however, for any order of the letters, because I could have just as easily said that my height was here. So I could have made my height there. In that case, I would have had C as one side, and then angle A as the angle between, and angle B as the hypotenuse for that right triangle. So I could have had half CB sine A. So we just have to have all three letters represented, and the angle always has to be between the two sides that we know the values for. So let's try it. So in this case, our area is going to be half of the two sides we know times sine of the angle in between them. So half of 32 is 16 times 20. That is 320. Sine 60 is our exact value. Our approximate value is 277. If you forget this, of course, you can just draw in your right angle. So here's my right angle. My base would have been 20. My height would have been 32 sine 60. All right, let's try it for an obtuse triangle. So in this obtuse triangle, 4 is my base. I'm going to put in a height. So here's my height over here. Well, in this big triangle here, my height is going to be 7 sine 30. So it still works that even for an obtuse triangle, I can use half the base, the side, and sine of the angle between. And in this case, I'm going to get, the answer is 7. And that's because sine 30 is a half. So we get an exact value this time. So explain to yourself and write down an explanation for part B. Why does the formula work with an obtuse triangle? And I will see you back in class.